So today we'll learn different kinds of properties of Laplace transform. So the first one is your the first translation property, or it is also called first shifting property. Okay, the first property is your first translation property or first shifting property. So in this property, what we learn? So if suppose Laplace transform of f of t is your f of p, then it says that Laplace transform of e to the power at into f of t, it should be f of p minus a. So this is called shifting property or first shifting property or first translation property. So what is that? If you know the Laplace transform of some function, let f of p, that is you say f of p you are getting, then you can, without finding using definition of Laplace transform, you can find out the Laplace transform of e to the power at into ft. That means if you know the Laplace transform of this f of t, then in order to find the Laplace transform of this e to the power at into ft, you use this first shifting property. So what is that? If Laplace transform of this f of t, if this Laplace transform of this f of t, if it is f of p, then Laplace transform of e to the power at into ft is nothing but just you replace this p by p minus a. A will get from where? That will be the coefficient of what? T, e to the power at. So this is directly f of p minus a. So let us see how can we do that. So just a minute. So how can you do that? Let's see. This is just we are going to trying to find out the Laplace transform of this, and we'll try to show that the Laplace transform of e to the power at into ft is nothing but is equal to f of p minus a, is equal to nothing but f of p minus a. So what we'll do? So first, your Laplace transform of e to the power at into ft. So obviously you know the definition of Laplace transform, that is what? Integration 0 to infinity e to the power minus pt into the function for which you are finding the Laplace transform. So here you are finding the Laplace transform of what? E to the power at into ft. So just I have substituted here e to the power at into ft. Then e to the power minus pt into e to the power at. So e to the power minus p minus a into t, f of t dt. So if you compare with this Laplace transform of your f of t, that from the definition, say, so what is the definition? Integration 0 to infinity e to the power minus p into t into f of t dt. This is the definition, and this after integrating, you are getting a function of what? You are getting a function of p. You are getting a function of p. Now, if you compare this definition with this line, so if it is e to the power minus p into t ft dt, then you are getting what? You are getting f of p. You are getting f of p. So here it is what? Now see here, p is also constant, a is also constant. You can say here, because you are integrating with respect to t. So p and a both are constant. So p minus a is also a constant. If P is a constant and A is a constant, so P minus A is also a constant. So if you compare with this, what you can write? We can write f of, we can write what? We can write f of P minus what? A. Is that clear? Just I have used this definition and I have compared with this. Similarly, here e to the power, here it is what? E to the power plus at into ft. Now, same thing, if it is e to the power minus at into ft, so if it is here, in the first shifting properties, if it is e to the power at into ft, then you are getting what? F of p minus a, if the sign of at is positive. So similarly, if the sign of at is negative, then here it will become what? It will become f of p plus a, same thing. So this is also a first shifting property or first translation property. So this also you need to memorize. Next, the second translation property is what? Second translation property is what? If you know the or second shifting property, if the Laplace transform of f of t is your fp, and there is another function g of t that is defined as f of p minus a if t is greater than a, and the value of gt will be 0 if t is less than a. That means what it says, that if we know the Laplace transform of some function that is f of t, that we know the Laplace transform of it is what? F of p, and there is another function that is related with this f of t, so that g of t is equal to what? F of p minus a if t is greater than a, and 0 if t is what? Less than a. Then it says that the second shifting property says that Laplace transform of g of t is nothing but e to the power minus ap into f of p. Then Laplace transform of g of t is what? E to the power minus ap into fp. This one. So this is the second translation property. So this also you need to memorize. And the proof is very simple. So what? We need to show that the Laplace transform of g of t is what? E to the power minus ap into fp. So how will you proceed? So let us find out the Laplace transform of g of t. So use the definition of Laplace transform. So integration 0 to infinity e to the power minus pt into g of t dt. Now this g of t has two values. One is f of t minus a, another one is what? 0. And these two values of g of t is separated at which point? At the point t is equal to what? A. At the point t is equal to a. That means when t is greater than a, the function g of t has some value, that is f of t minus a. And if t is less than a, then the function g of t has the value is what? It is 0. So this integration you have to divide into two parts. So how will you divide? One from 0 to a, and another one from what? A to infinity. So we have divided the integration into two parts. One is from 0 to a, and another one from a to infinity. Now you have to put the values of g of t at both the places. Now here 0 to a, that means what? T should be less than a. Is it not? Here integration is what? From 0 to a, that means t should be less than a here. So if t is less than a, the value of g of t is what? That is your 0. So just you put 0. So this first integration becomes 0. Then plus, next a to infinity e to the power minus pt, e to the power, then you have to put the value of gt. So here integration is what? From a to infinity. That means here t is what? Here t should be what? T will be greater than what? T will be greater than a. So if t will be greater than a, then what is the value of g of t? That is what? F of t minus a. So just you put f of t minus a here. So if you put f of t minus a, so ultimately this integration reduces to what? This one. A to infinity e to the power minus pt into f of t minus a dt. Then what we'll do? What? We'll put t minus a is equal to u. Just to put t minus a is equal to u. So the variable t we are transforming to another variable, that is u. So then also this dt you have to transform in terms of du. So just differentiate both sides. So dt is equal to what? Du. Dt is equal to du. And so since the variable t is transformed to u, so this limit of integration will also change, because this limit of integration are over t. Now you have changed this variable t over u, so you need to change the limit of integration over u. So first, when t is equal to a, then when t will be a, then u is equal to what? Then u is equal to how much? U
0.
U is equal to 0. U is equal to 0. Now next, when t is equal to your, when t tends to infinity, then obviously u will also tends to what? Infinity. You can't write t is equal to infinity, because infinity doesn't have any value. So when t tends to infinity, so obviously if you put in infinity minus a is what? Obviously it goes to infinity. So u is also tends to infinity. So our limit of integration a to infinity will change to what? Will change to what? 0 to infinity. So the limit of integration will be what? 0 to infinity e to the power minus pt. So this, since t has been changed to u, so t is equal to what? A plus u. So e to the power minus p u plus a into t minus a is equal to what? U, f of u du. So now here so p is constant because integration is with respect to u. So if you multiply here, so e to the power minus pu into e to the power minus pa. So e to the power minus pa, so e to the power minus pu into e to the power minus pa. So e to the power minus pa, you can take it outside of what? Integration, because it is wholly constant. So e to the power minus pa, just you take it outside, integration 0 to infinity e to the power minus pu fu du. Then the properties of definite integral, if you remember, if you change the variable by another variable, the value of integration doesn't change. So if you change u by t, then also there will be no change. Just simply, this is the properties of definite integral. If you change one variable by another variable, then the value of integration never changes. So just what I have did, I have changes u to t, so it becomes what? E to the power minus ap into 0 to infinity e to the power minus pt into ft dt. So this is nothing but what? This is nothing but the what? Definition of Laplace transform of f of t. So this is nothing but Laplace transform of what? F of t. And Laplace transform of f of t is what? That is what? F of t. So this is nothing but e to the power minus ap into what? Into f of t. This integration is nothing but what? This integration is nothing but your Laplace transform of what? F of t. Just definition, if you remember the definition. Laplace transform of f of t. And Laplace transform of f of t is equal to what? That is your f of p. So directly it has been written. So Laplace transform of g of t is equal to what? E to the power minus ap into fp. So this is your second translation property, or Sometimes it is called Heaviside shifting theorem or second shifting property also you can say. Now next is your change of scale property, the third property. Third property is what? Change of scale property. So what is that? That is also very simple. So if you know the Laplace transform of f of t is your f of p, then it says that Laplace transform of f of a t, Laplace transform of what? F of a t is nothing but is equal to 1 by a into f of p by a. So if you know the Laplace transform of f of t is your f of p, then the Laplace transform of f of a t, Laplace transform of what? F of a t, a is constant. So that will be equal to what? 1 by a into f of p by a. So proof is also very simple. Let's see. So Laplace transform of f of a t is this one. Use the definition of Laplace transform. So 0 to infinity e to the power minus fpt into f of a t into dt. Now what you do? Now you put at is equal to u. Substitute at is equal to u. So dt is equal to what? 1 by a du. So dt is equal to what? 1 by a du. Now next you need to change the what? Limit of integration, because dt t is changed to u. So when t is equal to 0, u is also 0, and when t tends to infinity, u also tends to infinity. So limit of integration doesn't change, that will remain as it is. So it is 0 to infinity. So e to the power minus p t. T means what? T means here u by what? A. So t is what? U by a. F of, and at is equal to what? U, and dt is equal to what? Dt is equal to du by a. So du by a. So this 1 by a, you can take it outside. So 1 by a, 0 to infinity, e to the power minus p by a into u, into f of u du. Then again just use the properties of definite integral. If you change the variable of integrand, then the value of integration never changes. So if you replace u by t, that means this is, if you have integration a to b, whether you remember or not, a to b, say it is what? F of x dx. So if you change the variable, if you change the variable x by another variable, say y, then the value of these two integral, the value of this integral or and value of this integral will remain same. There will be no change in the value of the integration. So that's, so if you change, this is the properties of definite integral. This is the properties of definite integral. So just I have changed u by t. So e to the power minus p by a into t, f of t dt. So then again, if you compare with the definition of Laplace transform, what was it is? 0 to infinity e to the power minus pt into ft dt. That is equal to what? That is equal to f of p. So whatever be the coefficient of t in the exponential, that should be f of p. So here e to the power what? Here e to the power minus p by a into t. So that is nothing but what? That is nothing but your f of what? F of p by a. So that is, and 1 by a is here, 1 by a is here, and this is, this part is nothing but what? F of p by what? A. Did you understand or not? So it will be more clear if you do some problem on that, some example on that. Let us see. Let us see the first example. That is also very simple. Now see here. That is very simple one. Now you need to find out the Laplace transform of what? This is using direct formula. So 7 e to the power twice t plus 9 e to the power minus twice t plus 5 into cos t plus 7t cube plus 5 sin 3t plus 2. Okay, so you need to find the Laplace transform of this. Then use the property of linear combination. So Laplace transform of this is nothing but is equal to what? You need to find, because all are related with what? Plus sign. So you can, in order to find the Laplace transform of whole function, you just simply find the Laplace transform of each term separately, because all are related with what? Plus sign. So linear combination properties. So Laplace transform of 7 e to the power twice t. Then again, Laplace, already I have shown you Laplace transform of C1 into say ft. C1 into say ft, and that is equal to what? C1 is constant, so you can take it out, C1 outside of Laplace transform. You need to find the Laplace transform of simply what? You need to find out the Laplace transform of this f of t only. You need to find out the Laplace transform of this f of t only. So this 7 is constant, so take it outside Laplace. So 7 into Laplace transform of e to the power twice t. Then your 9 into e to the power minus twice t. So 9 is outside Laplace transform of e to the power minus twice t. Then 5 cos t, 5 cos t. So 5 is take it outside Laplace transform of what? Cos t. Then what? 7 is outside Laplace transform of t cube. So Laplace transform of t cube plus 5 Laplace transform of sine of 3t plus it is what? 2. So Laplace transform of 2 or 2 into Laplace transform of 1, that is same thing. Now you already know that the Laplace transform of e to the power at, that is how much? 1 by p minus what? A. The Laplace transform of e to the power at formula, the 7 formula you have already got. So Laplace transform of e to the power at is what? 1 by p minus what? P minus a. So what is a here? A here it is what? 2. So that is 7. 1 by p minus 2 plus 9 into Laplace transform of what? E to the power at. A is what here? Minus 2. So 9 into 1 by p minus minus plus e to the 1 by p plus 2 plus 5. Laplace transform of what? Cos t. So Laplace transform of cos t is how much? P by p square plus what? A square. Laplace transform of cos of at. Cos of at. Cos of at. Laplace transform. The Laplace transform of this. That is equal to what? That is equal to p by p square plus a square. P square plus what? A square. So what is a here? Cos t is there. So a is what here? A is what? 1. So p by p square plus 1 square is what? 1 plus 7 into. Then you need to use the formula of what? Laplace transform of t to the power n. So what was that one? If n is a positive integer. So factorial n by p to the power what? N plus 1. So factorial n means what? 3. So factorial 3 by p to the power 3 plus 1, that is how much? It is 4. So factorial 3 by p to the power 4 plus p, this one, 5 into, now Laplace transform of now sine of at. So Laplace transform of sine of at is what? Laplace transform of sine of at, that is a by A by P square plus what? A square. P square plus A square. This is the Laplace transform of what? Sine of AT. A by P square plus A square. So A means what here? Sine of AT. A means what? 3. So 3 by P square plus A square. A square means what? 3. 3 square. 3 square is what? 9. Then 2 into Laplace transform of 1 is what? That is 1 by P. And then just simple. Then after this, just simplify and you will get the required Laplace transform of a given function. Is that clear? Now, before doing the second problem, one thing you remember. See, whatever with the formula we have got. So, whenever you are trying to find out the Laplace transform of any function, so be sure that the function which you have given to find out the Laplace transform, that function should be fitted on the in the what with the formulas. If not, then you have to make some adjustment with the function, and then you need to apply the formula, because you can't change the formula. If you know the Laplace transform of e to the power at, then you have to apply. If you have e to the power 5t, e to the power 7t, whatever, like this type of term is there, then you can directly apply there. But if your function is not fitted with the what, with the formula, then you need some adjustment or some correction you needed using some formulas, so that your given function should be in line with the what, in line with the formula, so that you can use the formula. This concept you must that is the very much important concept while finding the Laplace transform. So just to see the example 9, if you see, so it is what? Sine of twice t into cos of thrice t. Sine of 2t into cos of 3t. So now see, it is what? Sine t into cos t. So it is in terms of product. So we do not have any Laplace transformation formula for both sine and cos together. We have formulas for sine and cos separately, but we do not have formula for sine and cos together. So in that case, what we'll do? What we can whether we can find out the Laplace transform of this or not. Obviously, we'll try. So what you do, you know the trigonometric formulas all. So using that trigonometric formula, you try to separate the sine and cos separately. You try to separate it. So very known formula, 2 sine A cos B. 2 sine A cos B or 2 cos A sine B, same thing. So what I have did, divide by 2, multiply by 2. So this part, 2 cos A sine B, what is the formula? Sine A plus B minus what? Sine A minus B. Do you remember that? 2 cos A sine B, sine A plus B minus what? Sine A minus B. If you remember, then you can understand that. 2 cos A sine B, that is what? Sine of A plus B minus sine of what? A minus B. So A is your 3t, B is your twice t. So that is half is here. So 2 cos A sine B is what? Sine of A plus B. A plus B means 3t plus what? Twice t. That is your what? Sine of 5t minus sine A minus B. Sine A minus B means what? 3t minus twice t, that is what? P minus sine t. Now see, so earlier the function given to you to find out the Laplace transform, that was given in terms of what? Multiplication. But here we won't be able to use the formula for Laplace transform, because we do not have any Laplace transform formula for product of sine and cos together. But we have formula for sine and cos separately. So using these trigonometric formulas, this function we have transformed separately. So that is related with plus or minus, whatever it may be. Now just you use the Laplace transform here. So that is what? Laplace transform of this sine t twice t cos thrice t is nothing but Laplace transform of half of sine of 5t minus sine of t. And then half take it outside, then you Laplace transform of sine of 5t, that is what? 5 by p square plus 5 square minus sine, Laplace transform of sine t is how much? 1 by p square plus 1 square. And then just simplify it. Simplify, you will get the desired result. And just simplification. Then just simple simplification, and this is the Laplace transform of what? Sine of twice t into cos of thrice t. So in that way, if you get disconnected, so please join again, okay? Then next is your Laplace transform of sine of. Okay, so then the next will be your sine of sine cube twice t. This. So that very simple. You know the sine cube formula. That is what? 3 to the power 4 sine t minus what? 1 by 4 sine 3t. If you remember this formula, switch off your videos. Sine cube t. The formula is your what? Formula is your 3 by 4 sine t minus 1 by 4 sine of twice t. This is the formula. Sine cube t formula. If you remember. So why we need to use here? Because here you need to find out the Laplace transform of sine cube. But we do not have formula for finding the Laplace transform of sine cube. We have formula only for what? Sine t or cos t. We do not have Laplace transform formula for trigonometric power. So you can't find sine square, you can't find. So in order to find out the Laplace transform of sine square, sine cube, or sine to the power 4, whatever it may be in the power form. So first you need to reduce the power in terms of what? In terms of 1, by using the what? By using the your trigonometric formulas. So using this trigonometric formula sine cube t. So see here in both the terms, the power of sine is what? Here what? 1. So you can directly use the Laplace transform here. So see here. So if it is t, then only here it will be t. Here it is twice t. If it is twice t, then it is twice t, and this is just a minute. It's not. It is twice t. It will be 3t. Sorry, it will be not twice t. It will be 3t. sine 3t. So if it is 2t sine cube twice t, then 3 by 4 sine twice t minus 1 by 4 sine 3t into 2t, that is what? 3 into this twice t. So it will be 6t. So see here, 3 by 4 sine cube twice t is equal to what? 3 by 4 sine twice t minus 1 by 4 sine of 6t. Now see, the terms are what? Separated with single trigonometric function, and their power is what? Also 1. So now you can directly use the Laplace transform, because either you write this sine cube twice t, or you write 3 by 4 this. The meaning is what? The meaning is same. So here directly you can't use what? Laplace transform. But once you reduced or transformed the sine cube twice t in terms of this, where the terms are different and their trigonometric power is what? 1, and so you can use the what? Laplace transform here. So now use the Laplace transform and then use the formulas. Laplace transform of sine twice t and Laplace transform of 6t. You will get the what? You will get the what? You will get the required Laplace transform of the given function, that is your sine cube twice t. Similarly here, cos hyperbolic twice t. Similarly, cos hyperbolic cube twice t. So again, we have formula for cos hyperbolic at, but we do not have formula for what? Cos hyperbolic cube or cos hyperbolic square. So in that case, what we'll do? Again, if you remember the hyperbolic function that you have already got. So in hyperbolic function, cos hyperbolic t is equal to what? Cos hyperbolic t, not cube. Cos hyperbolic cube t is equal to, the formula is 3 by 4, that is similar to that, 3 by 4 cos hyperbolic, just a minute, cos hyperbolic t then plus 1 by 4 cos hyperbolic 3t. This is the formula. Cos hyperbolic cube t, the formula for this is your 3 by 4 cos hyperbolic t plus 1 by 4 cos hyperbolic 3t. So this cube part, because once cube is there, you can't use the Laplace transform formula. So we have reduced this cube means power part. In terms of power, there is what? 1 here, cos hyperbolic t and cos hyperbolic 3t. And you know the Laplace transform of cos hyperbolic t and cos hyperbolic 3t. Use the Laplace transform formula, you will get the what? Required Laplace transform of this. Is that clear? Now see, the next one is your Laplace transform of 1 plus t into e to the power minus t whole cube. 1 plus t into e to the power minus t whole cube. So you can't use directly the Laplace transform formula here. So what you will do first you break it. using a plus b whole cube formula. So just we have breaked it and separated this one. So now total here how many terms? 4 terms. So separately just you find out the Laplace transform of each term and then you substitute here, you will get the required Laplace transform. So let's see here first. So Laplace transform of 1, that is very simple. How much it is? 1 by p. Now next we need to find out the Laplace transform of t cube into e to the power minus 3t. T cube into what? E to the power minus what? 3t. So if you remember the first shifting property, what was the first shifting property? That if Laplace transform of f of t, if Laplace transform of f of t is your f of p, then Laplace transform of e to the power at into f of t, that is how much it is equal to? F of p minus what? P minus a, if you remember. So if Laplace transform of f of t is your f of p, then Laplace transform of e to the power at into ft, that is equal to what? F of p minus a. So the term should be of this like e to the power at, and if it is e to the power minus at, then it will be what? F of p plus a. If it is minus here, then this will become what? Plus. And if it is plus, then this would be minus. So now see here, you need to find out the Laplace transform of this. So now see, if you compare with this, so e to the power minus at into ft. If you compare with this, e to the power minus at into ft. So what is f of t here? What you can consider? F of t is what? T cube. But the thing is what? Whenever you consider f of t, but you need to know whether the Laplace transform of that, whether you are able to find out or not. So this Laplace transform of t cube is very simple. Use the formula of t to the power n. So factorial n by p to the power n plus 1. So t cube, that means factorial 3 by p to the power what? 3 plus 1, that is 4. So just to give it name is what? F of p. F of p. And f of t is what? Your t cube. Then using the first shifting property, what you can write? E to the power minus at into ft. So e to the power minus a means what? 3. So e to the power minus 3t into what? Ft is what? Ft is your what? T cube. This is ft into t cube is equal to what? F of p plus a. So f of p is what? F of p is your factorial 3 by p to the power 4. So factorial 3. Now p you need to change what? As p plus a. So a is what here? A is your 3. A is what? 3. So p you need to change by p plus 3. So factorial 3 by p plus 3 to the power 4. So this is. Similarly, the second Laplace transform of t into e to the power minus t. Again, same thing. So here also you need to use the what? First shifting property. First you take f of t as t. So Laplace transform of t is what? 1 by p square. And then use the first shifting property, e to the power minus at into ft, that is equal to what? F of p plus 1. So here a will be your what? 1. So that will be 1 by p plus 1 whole square. Then similarly here also, here you consider t square as f of t. And what is the Laplace transform of t square? That is factorial 2 by p cube. And then use the first shifting property, that will be reduced to what? Factorial 2 by p plus 2 whole cube, and then just substitute all values here, and then you simplify, you will get the required, what your required Laplace transform of 1 plus t to the power minus t whole cube. So this is the way. So you have limited formulas, but while finding the Laplace transform of any function, first you need to check whether that function fall under the under our given formulas or not. If not, then what should we do with the given function so that we can use our given Laplace transform, or we can use our given Laplace transform in that function. So that is the thing you need to do. So in this way you need to do. Similarly here also, very simple, that is Laplace transform of this, break it a plus b whole cube, then it here cos hyperbolic at into sine of bt. So see how you can separate it, because you don't know formula for cos hyperbolic at into sine bt. Okay, so how will you use the trigonometric formulas here so that you can separate it into single terms, single trigonometric terms. Similarly here you need to now see here in order to find this one, e to the power minus t into cos t into cos twice t. Now you don't know the formula directly. So if you consider this one as f of t, if you consider this one as f of t and e to the power minus t into ft, so this is nothing but the first shifting property. Now here if you consider this one as f of t, then also you won't be able to find out the Laplace transform of this directly, as already have discussed earlier. So first you need to transform it using the trigonometric formula to what? To single trigonometric terms, and then you use the what? Laplace transform. So first you consider this one as f of t, and then use the what? Trigonometric formula to separate the what? Trigonometric terms, and then use Laplace transform, and then from that you will get the Laplace transform of this part. So say that is your f of p, say that is your f of p, and then use the first shifting property, that is e to the power minus at into what? Ft, that is equal to what? F of p plus a. So here it is what? A is equal to what? 1. So f of p plus 1. So after finding the Laplace transform of this part, that will be a function of p. So in that, by using first shifting property, this p should be replaced, each p should be replaced by what? P plus 1, and then simplify it, you will get the required result or required Laplace transform. So in that way you can find out the Laplace transform of any function if that function can be put on the formulas, on the given formulas. If you can't put the given your given function under the formulas, so you won't be able to find out. So ultimately this here already it has been done. Now see, the next one is the second shifting property. Here, find out the Laplace transform of f of t, defined as this one. So here this is the second shifting property. So what is f of t, small f of t? That is t by capital T when the value of t will be less than t and greater than 0, and the value of this f of t will be 1 if t should be greater than t. So that is very simple. So what we'll do? So Laplace transform of this f of t. So from the what? From the definition of Laplace transform, 0 to infinity, e to the power minus pt into ft dt. Now the value of this ft, this f of t has two values. One, if t should be less than capital T, then its value will be t by capital T, and if the value of t should be greater than capital T, then its value is what, 1. So in that way, just you divide this integral into two parts. So one is from 0 to capital T and another one is from what, capital T to infinity. Okay, so if it is capital from 0 to capital T, so in that case the value of f of t will be what, your t by capital T. So t by capital T dt plus t to infinity e to the power minus pt into ft. So here t to infinity, so the value of this t will be what, greater than capital T. So in that case the value of f of t should be what, 1. Just you put here 1, and then simple what, this is the simple integration. So this capital T is what, constant, take it outside. So it is what, 1 by capital T, 0 to capital T e to the power minus pt into t, e to the power minus pt into t dt. So this is nothing but what, this is by parts. Use by parts formula of integration and then you integrate, you will get this one. And integration of e to the power minus pt is what, e to the power minus pt by minus p t to infinity. And then simple, this is the simple integration. Again you have to do one more time integration, this one, and then you put your what, this all limit of integration, just you put, and then you simplify, you will get the desired result. So whenever this type of function is second shifting property given, so just you need to check out at which point the value of f of t is divided. Then accordingly at that point you divide the integration into that part. Here only one point is given, maybe you will get more points where the value of f of t has been divided. Maybe you will get 2 points, 3 points, or 4 points, whatever it may be. So at each, so just you need to find out at which points the value of ft has been divided. Then accordingly you need to divide the limit, the means the integration into that part, into that many parts, and then you need to integrate. After putting the values of f of t, integrate it, you will get the desired result. Desired result. So this is your about the second shifting property. So here many problems has been done. So here it is what, t greater than pi by 3, t less than pi by 3. So it has been the value of this function is divided at the point pi by 3. So the limit of, whenever you find the limit, so it will be divided into two parts, the integration. One is from 0 to pi by 3 and another one is what, from pi by 3 to infinity. And then use the second shifting, you will get it. So these are the some exercise has been given. Just you go through that one, many exercises, and their answers are also given. Now in next class we will discuss about the functions of exponential order.